All right, what are parametric equations? I really recommend that you make T-sheets that have these definitions down. These are the last things you're touching. It's a busy week. You probably are not consuming this the way we'd like you to. So if you are not in my section, we have been making T-sheets for the past few weeks. So, you get 3 pages front and back. And so it's taken us some time, but we have everything stored and we can share that with you. But you will have to send me an email and I'll send you that as a response if you'd like to see what I'm talking about. All right, so parametric equations, what are they? They are the x component, y component, and z component of your vector form of the line that I showed you in the previous WebAssign. So the first step is to find R0. R0's, I just pick it to be the A. You can pick it to be the B, whatever floats your boat. But probably this is a good idea to stick with the format I have because answers in WebAssign might not match. Find V, the direction vector, next. That's my direction vector. I'm using exactly what was in the book and what was in the last WebAssign so that my numbers match up with theirs. 7 minus 10, 7 minus 4, minus 2 minus 1. And so I'm careful with the minus signs. And you can't do this, but I just did the math, arithmetic, and I got these all to match up. Step 3 is to peel out of this x of t, y of t, and z of t from that vector equation of a line. So r of t is this guy right here, position vector, direction vector. Bring in the t, so I get minus 3t, 3t, and minus 3t. And then combine the two. I did it in one step. So I get 10 minus 3t. That's fine. You just have to be careful with minus signs and make sure you got all the signs correct. And then turns out that this first component is your x of t, the second component is your y of t, and this third component is your z of t. And see, they match up exactly the same. So that's what we call the parametric equations of that line. All right, so last problem on this, I think this is the last problem. Yeah, this is the last problem, so I can go through this one too. So graphing this parametric equation, there's a way to do it on Mathematica. So let me pull up the code. The easy way is just to, I've got it down here, so just to actually type in parametric plot with a bracket, a curly bracket, the x component, which was square root of t, and the y component, which is my minus 4 minus t. And then I know that t has to start at least 0 because if I put negative numbers in here, it's going to scream at me. So I put in t equals 0 to 5, and I see that I get this. Now, you're asked for the arrows too. How do I tell the arrows? Well, I can use my head. As t goes larger and larger and larger, I'm going to get my x value is also going to get larger and larger and larger. So the direction has to go down like a waterfall. However, you can also get Mathematica to do this. I do have, it's a little bit more complicated. You first set up your equations. X is equal to square root of t, and that's double equals. Y is equal to double equals 4 minus t. You do this weird command here. Perfectly happy to send you this code if you want to try it. And then you put on all this code and it gives you the arrows as you want. And you see that it's like a waterfall going down. So this T is like, I just say it's like someone started running on a track and it tells you the direction they're running. So as T goes up, think of T as being seconds, their direction is going along this track. And if I have a funky looking curve, that direction matters. And so the parametric curves also give you a direction that you're running. Okay, the second part of this, you're asked to transform this into a Cartesian without the t's in it. They don't want to know how fast you're running on the track or what direction you're running on the track. They just want a formula for the track. So the goal is to get rid of t. So step 1 is to solve for t on the x. You don't have to do it that way. You can solve for t on the y. I did it for the x. So I square both sides and I get t is equal to x squared. I sub that into y. So t is x squared. I put that into the y where t is. I replace it with x squared and I get 4 minus x squared. And look at that. it's exactly the same thing as what WebAssign has. And so WebAssign is correct again.